Hi, good morning, or good afternoon, or good evening, depending on the time that you're watching this video. I want to continue lecturing, and hopefully, you have time to watch this video before Saturday. The first topic I want to talk about is combinations. 1.4. All right, combination. What is combinations? Combination is um, a way to calculate how many different ways different ways we can select a group of R objects from a group of N objects. And when you think about it, for example, right? Say we have 5 letters A, B, C, D, E, and we want to select only 3 of them. How many ways can we do it? Sorry. All right, how many ways can we do this? Well, one way to think about it is that you have 3 positions. All right, you want to select 3. All right, so first positions, okay, here, first position here, all right, you can select 5 5 letters. You have 5 selections. But once you select the first positions, right, the second positions, oops, the second positions now have only 4 letters left to put it in, right? Then the third positions now have only 3 possibilities because you already select 1 in the first positions, right? So you have 4 letters left, okay, for the second positions. Once you select the second positions, then you have only 3 letters left for the third positions, right? Okay, so that's like if you calculate this would be 60 ways, right? Is that right? Yeah, 60 ways to do it. But however, okay, however, there are, okay, if we do it this way, that is like 5 multiplied by 4 multiplied by 3, okay, there are repetitions among, sorry, there are repetitions among the selections. What do I mean? Um, for example, A, B, C, right? In this way, it would be the same as A, C, B, same as B, A, C, same as B, C, A, C, A, B, and C, B, A. So all these 6 will be counted as 1, right? Because we only we are not really care about the arranging among the 3. We want to know just how many ways you can select 3, okay, out of 5. Okay, so when we do it this 5 times 4 times 3 times 1 like this, okay, the order matters. But in when we only interested in the 3, we don't really care about the orders, right? So um, all these uh, ABC, ACB, BAC, BCA, CAB, and CBA count as one. And the same thing as if we do, other selections, um, ABD, all right, then ADB, all right, BAD, BDA, and so on and so forth, we count as one. And if we keep doing this, until the last combination, let's say it will be C, D, E, right? In this case, C, E, D, D, C, E, and so on and so forth, we count as one as well. So if we do it like this, we know that our numbers of 60 ways, all right, is 6 times more than the usual, because all of these 6, that use a stronger color, this 6 will be counted as 1, right? So the numbers that we have originally, the 60 ways, would have to reduce by 6. So what do we do? That means um, we would have, so sorry, so the number 5 times 4 times 3, we have to originally have to divide it by 3 times 2. So it becomes just 10 ways of extracting it. Okay, 10 ways we can actually write it all down, like brute force, right? A, B, C, A, B, D, A, B, E. Then we begin with B, B, C, D, okay, B, C, E, okay, and is that right? Yeah, C, D, E. Do we have all? Oh, I forgot. And then A, C, D, A, C, E, right? And then A, D, E. Okay, so we have 6 with A, then have B, D, E, okay, of group B, and then C, D, E. So these are the 10, okay? Given that all the alignments of A, B, C, A, C, B are the same, so these are all the 10 that we have, right? Okay, so in general, okay, we have in general um, if we have as n times n minus 1 up until n minus r plus 1, okay, represents the number of different ways that a group of R items could be selected from n items. When the order of of selections is relevant. Okay, so let me highlight when the order of selection is relevant. But if we don't care about the order of the order of selections, then you have to divide by how many ways those selections can, you know, align among themselves, like in this case. So, right, keep continuing, right? And as each group of R items will be counted R factorial times, right? So the therefore the number of different groups of R item oops, R items from n items is n minus 1 up until n minus r plus 1, okay, over r combinatorials. So when we write it this way, is as if n factorial over n minus r factorial and then r factorial. Okay, so this in general we write it like this, and it's, you know, it's like, usually I would call it n choose r. Okay, that's how people usually you know, call it like this, n choose r. Okay, that's the terminology. All right, it's like how many different ways that you can select r objects, okay, from an n objects. Okay, more example. More example, all right. You want to choose, um, let's say, a committee of 3. See, is to be selected from 20 people. How many ways, okay, are possible? Right, easy, right? It's just 20 choose 3, like that. And when you write it like this, it's just 20, 19, 18, and 17 combinatorial, all right, 17 factorial, and then you have 17 factorial, and then 3 times 2 times 1. Why do I like write it like this? Because 17 factorial can be cancelled, all right, and then you just cancel 3, then you get 3 and 2, then you get 3 here. So it's just 20 times 3 times 19. It turns out to be 1140, all right, ways to do this. All right, one more example maybe. All right, let's say a group of 5 women and 7 men. Okay, all right, let's say we have a group of 5 women and 7 men, and from this, right, we want to select 2 women and 3 men for committees, for a committee. Okay, so from these 5 women we want to select 2 women, and from these 7 men we want to select 3 men. Well, first approach is that we can first select women first. So among women there are 5, choose 2. Okay, for women, right? And then for men there's 7, choose 3 for men, right? And then after we have select 2 from women and 3 from men, then we can do combinations between men and women. So we just multiply the results. Okay, so 5 choose 2 for women, it's just 5 times 4 times 3, right? 3 and 2. So these are 2, 10, right? And men, 7 times 6 times 5 times 4. So this is 4 and 3, all right? This is 35. Okay, so total will equal to 10 times 35 equal to 350 ways to do it, right? However, the question is not end. What if 2 men, okay, refuse to serve together in the same committee? All right, let's say there are 2 men who are like enemy or something, and they refuse to be together. Now this makes things a lot more complicated, right? I mean, well, not that a lot more, but more complicated, because 2 men doesn't want to be in the same committee. One easy way to solve this problem is that, what about we find ways that they will be served together and deduct that from all the possible ways, because we know that there are a total of 35 ways to select 3 men from 7 men, right? So let's see that. So there are 3 positions for men, right? Let's put these 2 men together, right? Let's say we put these 2 men, the first guy and the second guy, right? So they already occupy the first 2 positions. So the last positions, okay, there are only 5 men, there's the 5 men available, right? So now this is like the 5, we're finding the way that these 2 will be served together, all right? So let's say they are served together out of 3, that means there's only 5 ways you can select the third positions, right? So this is about 5 ways that these 2 men are together, right? So, and then therefore there are 35 minus 5 equal to 30 ways they are not together, right? So because there are 35 ways total, all right, 5 ways that they will be together, so deduct that from the total different ways, so it's 30 ways. And if we want to multiply that with the woman, which is 10, so there's 300 ways that we can select 2 women and 3 men, where 2 men are enemy, doesn't want to serve together. All right, that's it for this first chunk of the lecture.